hello to Noam. Hi, Noam. How are you doing?
Hi, good. How are you doing?
Good to see you. So Noam is joining us. Are you based in Israel?
Yes, that's correct.
Yes. So I think our partner was telling me that you are kind of local to him. And so Noam is with Inziv, and he'll be telling us about emerging trends in micro LED chip architecture and metrology and inspection. I think, from what I understood, specifically, you'll be telling us more about accurate and high throughput EL inspection and how, what parameters one needs to handle in terms of color and wavelength, the size variation of micro LED and other parameters. So yeah, very important team. I think, this sort of inspection is almost vital for manufacturing of micro LEDs. So yeah, so we look forward to your presentation.
Terrific. Thank you so much for having me. Thank you to TechBook and to microLED Connect. Appreciate it. Appreciate the opportunity. I will try to stay within the time allotted, despite the number of slides here. So I'm going to move efficiently here. Uh,
Yeah, I can see you have 38 slides, so good
Yeah,
luck.
exactly. So buckle up. But really, always happy to have questions at the end as well, of course. So just a brief word about our company. We were established in 2019, as we noted already, based in Israel. We do have 25 employees. Our main offices are here in Israel. We also have presence in Taiwan and Korea, and we are already working with leading companies across the display industry. Our vision is really to be the leader in micro LED testing and inspection. And we view that as really a critical step in enabling the next generation of displays. Just to briefly explain why we feel and have seen that inspection is such a critical problem, essentially, of course, quality control is a really important part of the manufacturing process in order to detect the LEDs and make sure they're working properly. And specifically with micro LEDs, as I'll outline briefly in a moment, there are some very serious challenges that exist in micro LED, which make it even harder than usual. And when we have these kinds of problems and defects are not detected at an early stage, then that of course lowers the yields of the production, and that in turn raises cost both for manufacturers, and that gets passed on to the consumers. And that's why there's really this critical need for effective inspection, and is really we view as one of the major keys to really push forward microLED as a major player in the display world. One word also of introduction is that we have come to understand that photoluminescence, although it has its place in testing micro LEDs, is not really the ultimate solution, as far as we can tell, for this sort of mass inspection. Photoluminescence, as is known, is a photo excitation. So you're using light to excite the LEDs, which is very fast, and you don't have to touch anything. So that's always a positive because there's no damage. It doesn't matter what the chip size will be. The problem is that it's not so accurate compared to EL, which we'll get to in a moment, to electroluminescence. It's not quite as accurate. Obviously, you can't measure any sort of electrical information because that's not where the excitation is coming from. And in general, since we're heading towards a device which will be powered through electroluminescence, the testing that is not going to be through an EL method is not really an accurate representation of the eventual excitation. And so that's why our methodology, though certainly not exclusively, but our real focus is on EL, is on electroluminescence. We have found this to be, and we get this feedback from all the players we're working with as well, it's the most accurate testing for micro LED chips. It gives you that electrical information, and again, it's going to replicate what the eventual use will be. The challenge with electroluminescence is that, first of all, if you're going to be contacting the chips and the surrounding architecture, then there is a real risk of damaging the sample, especially repeatedly. And the main challenge, perhaps, in the industry is that it's very slow. At least the standard EL prober is very slow. If you can do, let's say, one LED per second, if you talk about a micro LED wafer, which could have as many as 6 million LEDs, you're talking about absurd numbers of maybe 2 months to just do one wafer. So that's obviously